faculty member, Institute of Management Sciences, Lucknow University, welcoming our Honorable Vice Chancellor, respected Professor Alok Kumar Rai, and respected OSD Sir, Professor M.K. Agarwal, Institute of Management Sciences, Lucknow University, and all the faculty member of Institute of Management Sciences, Lucknow University, who have given opportunity to organize online lecture on the topic data warehouse and business intelligence in information systems in industry by IT industry expert speaker, respected Mr. Mhd.Azhar Siddiqui, who is alumni of Lucknow University. Currently, he is owner and CEO of B3 Digital Solutions Private Limited, UK, which is a healthcare analytical platform saving human lives throughout the globe of cancer patients through artificial intelligence empowered platform. He has 20 years of experience in IT industry. Azhar sir have worked in so many IT industries, started his career after completion of MBA program from Lucknow University in Global Infotech, Chennai, India, Hexaware, USA, as Chief Technology Officer, Royal Bank of Scotland as Chief Technology Officer, and Al Hilal Bank Abu Dhabi as Chief Technology Officer. We are proud of him, and I welcome and request Mr. Mhd.Azhar Siddiqui to start the session. Before starting, there is a request to all participants that everybody should mute the audio and video so that the smooth functioning of the lecture may be possible. If anyone is having questions and queries in between the lecture, after the completion of the session, they can ask in the last. Now I request Mhd.Azhar Siddiqui to start the session.
Hello everyone, I hope I'm audible. Can you confirm?
Yes, sir.
I'm audible to you all. Ashish, thanks Ashish and the entire Lucknow University team for having me here and giving this opportunity to interact with you guys. Yeah, so if you have any questions in between, you can also type in the chat. So I'll take those questions towards the end of the session. Yeah, so first of all, Ashish has given a brief introduction about myself. So, post that I work for several IT companies in India and overseas. And most of my work has been into data warehousing and business intelligence space. Lately, I've been also doing a lot of AI and that kind of stuff. So I have my own venture. Right now I'm in UK, as you said, and I'm extremely proud and excited to be here and present this, a short session on data warehousing and business intelligence, which I'm passionate about because this is what I've been doing all through my life. So yeah, so let me start with a short presentation so that, and then we'll take it forward from there. So let me just pull up the slides. I don't know. Allow me a minute. Yep, so here it is. I hope So I'll turn off my camera because I think not presenting it. So you can using business intelligence industry deliver an example as to okay, turn over. Hello. Sorry, I think there was some got disconnected in between the Zoom session these days because of Corona. So there's sorry for that. Yeah. So let's begin with an example. As I was saying, if I am not audible, please do let me know. So let's take an example from financial services, maybe a banking services that we typically use in our daily life. So we know that we all have saving bank account. We do transactions through internet banking. We use mobile banking as well, mobile apps these days. We can go to ATM, withdraw money, or we can go to branch. We can deposit money, withdraw. We can do cash payments. We can transfer money. We can do a lot of stuff, and we can also and things like that. So we deal with banking services. We use banking for rate so that to this of data in one place. It's a warehouse is bringing data in a reason. Why it's disconnecting for some reason. It doesn't happen normally. Yeah. So, sorry, services, the three different products of the banks and for our use, and all this information that is basically being used by different customers and different other sort of different sorts of products that we use for our daily needs. That's this information which is generated. This is stored in a warehouse, and this information stored in a certain way so that the top management can use this information in taking decisions and planning the business, and with respect to understanding how the business should be, what should do it. For example, they have to plan what should they do in terms of looking at different products, how they're performing, or different customer needs, and so on and so forth. There are different kinds of use cases that we can discuss about when it comes to top management, and in which they need data for taking decisions and planning their business. So this is what data warehouse is for, and it helps you track the business performance. So what we do is bring data into one place and we do a trend analysis. We'll look at it like how the 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 business has been doing last 2 years, 3 years, 6 months, different quarters, so on and so forth. And then you sort of like do trend analysis, and then you can plan your business for future, and you can build your strategies around what should you do around meeting your business goals, and so on and so forth. So basically this typical data warehouse is being used by either by top management executives or functional heads who are responsible for planning and decision making. So that's why it is a very important component of the entire information system. So this data warehouse is normally typically downstream systems. Why we call it downstream? Because this is the data which is put into data warehouse is normally uh, loaded into data warehouse at the end of the day, because when the entire business is closed, or when data, if the business is 24/7, then there's schedule which is decided when the data is going to be moved to data warehouse for it to persist in data warehouse in a certain way, so that that could be further used for analysis. Now, once data is into data warehouse, it has to present it to the users for them to be able to take look at the data, understand the trends, and make decisions. And sometimes we also to give them insights, you know, um, forecasting for future planning. This is where we use machine learning and artificial intelligence in business processes and in typical data warehouse. So here what happens is like you have tools and technologies which is which aggregates data um, at different levels based on what sort of KPIs or key performance indicators that business would like to look at for them to be able to take plan their business and take decisions. So then this is presented in a visual form to the users, and the users can at a click of a button get reports. So this is what the cycles talks about. Right? So so going for the further, if you look at how the system is designed in data warehouse, as I said, so there are different ancillary systems, and there can be various other kind of systems. For example, suppliers, or it could be your partners, or it could be your typical operational systems. So you can get data into. So all these systems are normally used in day-to-day basis when people interact, or the business when the business is being run. This data is pulled out from this. That's called extraction at a different levels. At maybe it's done at the end of the business, or it could be done scheduled at in a scheduled way, maybe every 2 hours, 4 hours, 6 hours, or it could be real time sometimes. I mean, as the business goes on, the data is being moved at the same time into warehouse. It also happens. We have real time data warehouses. When the data is moved, so before it is put in the data warehouse, it has to go through different stages, which is where we do data quality checks, cleansing, data harmonization, integration, to apply business rules, and then it goes to different data warehouses. A data warehouse could be one enterprise-wide, or it could be a combination of few data warehouses. So, and this is organized in certain database schemas, which are nothing but aggregated schemas. When we say aggregated schemas, it means data is aggregated in a way so that this users doesn't have to really do aggregations. For example, you can say, like, I want to say average quarterly sales of a certain product over quarterly sales of a certain product in certain region. So you will keep that data ready, like quarterly sales, total volume, and volume versus total amount in a particular region, which is predicted for a particular time frame. So we just have to show that to the users. They can just execute the reports. It will be there on their screen, and it's quick and fast because they don't have time to wait for the reports to give them the data. So that's why the data is aggregated and kept in a way based on what KPIs are expected by the business users, because they don't have really time to wait for reports to generate, pull the data out, generate, and show it to them. They have hardly few seconds. So that's why it's very important for them to or for the technical users to present the data that they want in the form of information at a click of a button within no time. So all of this information is critical. It's very important, and therefore, I mean, we have to understand. So therefore, there are different systems, and sometimes they are interlinked. So all of these informations are governed, and sometimes business definitions and all this different kinds of references that business uses. This is why we create data catalogs that we see at the top on the right hand side, where you have it's a library of you can say it's a dictionary or it's a library where you have different definitions and different rules and all that business rules defined into this governed data catalog. So the top screen is all about that. And the bottom, you see those 3 points. These are the ones which I just said. So normally data warehouses are time based because you are looking at the data from a specific time frame perspective, and there can be different viewpoints for different users, top management users to look at the data. So therefore, you sort of like create a data model which can help them to look at the data from various perspectives, from various viewpoints, from various angles. But this is all going to be time based. So because they look at from a specific time frame, like for which particular year, from which year to which year, which quarter, which quarter, as you hear a lot, because they have to do trend analysis. They need to see how the business is doing, what is expected to be done, and so on and so forth, for them to be able to take decisions. Yeah. So I hope you're able to follow me, because this is all about data. So, and anything that you do as a user, as a consumer, that is stored in a data warehouse. And because business wants to know what you're doing and what your needs are, how you're using their products, and so on and so forth. And this will help them, plan their business. So in a way so that it can serve you better, and they can also have more revenue from it. So going further from here, so this is a typical screen dashboard, which a particular business leader, the top management will have a screen, to look at it. It will present different KPIs in the form of matrices, graphs, charts, and then you on the left hand side you'll see there are different options they can select, deselect. There are filters. They can apply any sort of filters based on top, based on time frame, based on geography, based on product type, products, anything that's this particular report or this particular visualization or the dashboard is built for. The dashboard is normally a combination of reports. So what you do is you present different KPIs for trend analysis, forecasting, and planning to the business users. And these business users are normally executive people like CEOs, CIOs, CTOs, those people, or it could be functional heads. So that's how this is presented. Now going further, if you look at like how do you basically process this information into database? So for that, what you do is you create a database design, because you need to store that information or this data into your database, and this information will then help business users, as I said before, to plan their business and take decisions. So therefore, I mean, so what you do is you can store data into databases, different granularity. Granularity, I mean, is the grain of the data will depend on how you aggregate them. You can aggregate them based on, let's say, a daily basis. It could be hourly. It could be weekly, monthly, yearly. It could be geography-wise. It could be regional data. So basically, when you present certain KPIs are nothing but measures like total sales, total volume, total revenue, total loss, gain, blah, blah, blah. All those numbers that you talk about in terms, which helps um, how the business is doing, how the product is doing, how services are doing, how different quality metrics is, and so on and so forth, which helps you know how the health of your business, right? So this is what the grain is. So when you build your warehouse, you design your warehouse, you look at like what grain you have to maintain in your database design. And then based on that, you will write your data aggregation programs or scripts or algorithms, whatever you call it, uh, to populate those databases once it's designed. For example, you look at it, sales by product, region, time. So you will aggregate data based on that. So that when business users will pull that data out from the database into a dashboard, it doesn't really have to do all this aggregation on the fly. It is already in there. Yeah. So hope this is clear until here. Up until here, if you have any questions, you please keep writing in the um, chat box. Uh, there's a lot of noise at the back. I'm not sure if someone's is someone at the railway station or somewhere. I hear a lot of noise at the back. Can you turn off your um audio, please? Can you mute yourself? Hello? Can you please mute yourself? I hear a lot of noise. Thank you. So yeah, so there are different styles which are used in basically designing data warehouse. So normally this concept was given by Kimball, and then later on Inborn came up with another concept. How should you design your data warehouse? There are different styles, and then later on few more styles came up like hybrid and spoken wheel and so on and so forth. What is Inborn, Kimball, and hybrid and spoken wheel models are basically, these are nothing but how should you create a data warehouse? Should you first, you should take a top-down approach, bottom-up approach, hybrid, or you create like a spoken wheel, like you have a cycle tire, there are spokes, they're connected to wheel through a central hub. So here, and Bond says that, boss, what you do is you first create data marts, small databases, for low level kind of reporting and analysis. And then once data marts are more functional, once they are populated, then from there you take data and put into data warehouse for consolidating the industry-wide or enterprise-wide data into one platform. The Kimball says otherwise. It says, no, you first do data warehouse. Once you have all the data in one place, then you take out the data, whatever you need, and put it into a data marts. And these data marts can then be used by functional users. But then there are hybrid approaches, use a combination of both. And then spoken wheel is basically you create a hub where you have all your reference data, master data, all those data sets, rules, business catalogs into your hub, and then you sort of like pull out the information, whatever you need, and give it to the users like it's in the wheel, right? Your spoken wheel model. Yeah, so now what happens is like in a typical design, we use star schema, snow, hybrid. And the star schema is like you have one table and there are other tables connected in a star fashion, right? And snowflake is like it's further split into more tables. And hybrid is a combination of them. Now, uh, to give you an example, if you want to understand this a bit more, take an example like a product, time, and sales. So, or a region. Uh, so what happens is like, you have all the measures put it into one central place, and all this product, region, these two different tables are connected to this central table. That becomes sort of a star-like fashion. But if you want to really see, say, region-wise, and you want to go, the region is split further into zones and cities and countries and, zones, cities and areas and also so on and so forth, it goes a little bit more in depth. So what you do is you start splitting your regional table further into more detailed one, and you go a little in depth from, let's say that region may say it's North India, South India, East India, whatever you want to split it in that on that basis. And further you can, for example, let's take an example of telecom. They have circles, and the circles have further, different geography wise, they split it into cells. So that's why, I mean, the business would have different kind of classification. So you have to basically do those based on that classification. You do create your database kinds designs. Sometimes that's called snowflaking because you're further splitting the tables into more tables. that becomes a more complicated, and it affects the performance when it comes to reporting. So in hybrid is a combination of both. It sometimes you can't avoid snowflaking, sometimes you can, and so it's preferred to have a star schema by the way. Yeah. So once you have design schema and everything is designed, it's physical design it's been done, and then you have to bring the data from different operational systems, source systems, into your database that you've designed. That's the process, and it's called data extraction and loading process. So we create pipelines for populating these data warehouses, and these are the populations, as I said before, typically is dependent on they can be this can be scheduled, automated, it can be manual, it can be scheduled uh, at certain time frames, or it could be automated on demand. So there's different um, loading frequencies or loading methodologies used for populating those data warehouses and monitoring and governing the load process. Once the load is done, then BI applications come into the picture, and this is where these applications would again basically pull the data out from this data warehouses and present to the users in the visual form, and then there are dashboards, reports, and interfaces basically for end users to use. So that's the typical life cycle, or typical components you can say, which is used in um, data warehouse design and implementation. So this is how a typical star schema look like. If you see this, how does it look like? You have a central table, and there are a few tables connected to it, and there are certain tables that again split into more tables. So this is how the schema or database schema will look like. We call it normalization. Normally, these schemas are denormalized. Now, denormalized schemas, normally we maintain a two normal form, because the more you normalize, the performance will go down, because it has to bring in data from more tables. It has to join, it has to apply constraints, so on and so forth. It becomes slower. So it's better that you denormalize it, keep it simple, so that aggregation pulling is fast, so the data can be pulled quite quickly. And for it, the data to pull the data quickly, so what we do is we also to index the data using different indexing strategies. We partition the tables so that you can run the queries on the database data sets in parallel. So with partitioning enables you to apply parallel concept of parallelism, and you denormalize it, so you don't have to really go to many tables and pull data from them and then aggregate them, apply constraints, joins, and so on and so forth. It slows down. So this is the basically a typical model data warehouse has. So I'm giving you all this information for you to just know what data warehouse is basically and how it is designed, and the entire life cycle of it. So if you get to work on data warehouses in future, if you get a chance to, you would have a fair idea. So I just said I spoke about data mart a bit. So the data marts are they are subset of it. Data warehouses basically, let's say that you have a sales, you have marketing, you have operations, so and you have different departments, finance, maybe provisioning, so on and so forth. There are hundreds of departments that could exist in organizations, and those so the data from all organizations will all the departments go to data warehouse. But if you talk about just one department, or maybe a combination of two, so for the way you have coined the terms for your company, so therefore, I mean, this smaller sets becomes data marts. So data marts are typically, that's what inbound says. You first build data marts, then data warehouse. So instead of you just going big bang, you first go step by step. That's what inbound says, but Kimball says first build data warehouse. So here, data marts are nothing but small single subject data warehouse subsets. So this is done. This is more manageable because you have smaller data sets. You can roll out quickly. You don't have to really pull data from hundreds of systems. It's simpler, easier, so it's more manageable. And this, because it's a smaller one, it can it's used by functional users, typically a business unit or functional users uh, in a particular business unit to for their purposes in for design, decision making, and planning, as I said. Yeah, so So once you have data into your data warehouse, what happens? Tools to build cubes. These cubes are multidimensional, and multidimensional in the sense it allows you to uh, do three-dimensional analysis or multidimensional analysis. You can go from one place to other place, like you can do slice and dice, drill down, drill through so many things that you can do with this data. Like the bread you use, right? The bread that you buy from market has slices. So you can take one slice out and put it in some other place, and you can take another slice out and put it in some other place. So it's like a slice and dice. So you can do drill down, drill up. You can go wherever you want for you to do different kind of analysis. So you can have a multidimensional view of your data, of your business. So that's what cubes are. So cubes will store data, index it in a way so that you can just pull out, pull in, go whatever level you want. It's like assume it like you're on a tree and you have different branches. You can jump over from whatever branch to whatever branch in a tree. You can go at the top, at the bottom, at the branch, or you can go to anywhere you want. So in a click of a button, so that you can see your business from different viewpoints. You can do different kinds of combination. You can try different kinds of permutations and see how your data looks like, how your business looks like, or what you can do with with this data for your business planning. So this is OLAP, online analytical processing. This is what Cube is, and it's basically used in both operational data warehouse systems. So it also provides a GUI, and it's normally for analytical processing. So it stores data inside. Now there are different types of OLAP systems. This is one snapshot to tell you how OLAP system works and what it is. So if you look at it, there is OLAP UI, there's an analytical processing engine, there's data processing logic. So it pulls data out from operational system and stores it in the cube. Or you can pull out data from data warehouses the way you want it to store the data, so that you just don't have to run it will not execute any queries at the back to get your data from operational or data warehouse. Instead, it's going to get the data from the cube itself, because it's going to store it in a way that you want it to be stored. It's even faster and quicker. So, so, so this is all about queues, and it stores sometimes in memory, sometimes on the file systems, for you to get quick access to it. Yeah. So now data warehouses typically used by top management or functional users. So anyone at the executive levels will need data warehouse, and if you have to deal with, you have to. Lists are also needed in data projects, and typically wherever data warehouses are used. It's used everywhere in every industry. There's no industry which doesn't have data warehouse. Every company, every industry has. Then you will have to have managers, project managers, technical project roles. So these are some of the typical roles that if you take on in future, you encounter data warehouse in your job. Yeah. So that's all I wanted to give you, present to you, and give you information data warehouse. So if you have any questions, please go ahead and throw them at me. I'll try to answer as many I can. Yeah.
Okay, we are very thankful to Mr. Mhd.Azhar Siddiqui, who have given a very special lecture related to the IT industry and the topic data warehouse and business intelligence, which is further used in the information systems as decision support data and decision support system in various industries like banking, telecom, anywhere it may be. It is very useful for the students for building their further career pursuit. If anyone is having questions, may ask. and can write in the chat box. And Azhar sir have shared the email ID. You can write the question over there and we will come back to you.
अभी बाद में बात करेंगे थोड़ी देर 2 मिनट बाद.
Okay, I request Dr. Vijay Shankar Pandey to give vote of thanks to Azhar sir.
Thank you, Dr. Ashish Sonkar, sir. I, Vijay Shankar Pandey, Assistant Professor, Institute of Management Sciences, and team is highly obliged for your contribution as industry interaction on the topic data warehouse and business intelligence in information system in industry. Sir, you have enriched us with very practical knowledge such as data designing, data execution, end-use analytical intelligence, summarization of data, optimization of data, data mart versus data warehouse, OLAP system, roles of DWH, and etc. Sir, you have also enriched us with the use of database data in banking and finance. It is also helpful in business evaluation, making and formulating marketing strategies, etc. Now, as I have understand from your lecture, sir, you have told in the previously we have learned the capital mobilization is the system of economy. Then it comes to the labor, and now it is the data. So data is in current scenario as like the petrol. One can use to build their economy or the else. Sir, I am highly obliged for your contribution because you have spared your time and share and join us from the London, making the synchronization of time and all those things. Sir, I am also thankful to our Honorable Vice Chancellor, Sir, Professor Alok Kumar Rai, and OSD-IMS Professor M.K. Agrawal, Sir, who inspired us to organize such program. I am also thankful to all the participants present in the session, enriched their self, which definitely useful for them in near future. I am also thankful to all the committee members who given their 100% to organize the program. Thanks to all the participants. Now I am handing over this session to Dr. Ashish Sonkar, sir.
Okay, special thanks from Institute of Management Sciences faculty team and staff, and on behalf of participants, our students, to Mr. Mhd.Azhar Siddiqui, who have spared time, valuable time from his busy schedule. And it is our request in future that Azhar sir will join us for special lectures related to business management and information technology. Thanks, sir.
Thank you,
Thank
sir.
you. Thank you very
sir.
much
Time
as well. Thank you.
Okay.
Thank you for giving this opportunity. Yeah. Thank you.